Hello everyone. At first, I would like to thank to Dr. Jean Philip, Dr. Philip Kavang, and the organization for giving me an opportunity to talk about my work. And today, I would like to talk about the, the subject is semiochemical research and application, and also how to integrate this field with the biodiversity or something else. You know, in such communication, the insects use almost the same, like us to communicate with the other, from sound, light, touch, and most important in insects is the chemical. And in communication with the other insect use chemical, we call it that it's a semiochemical, and the study on this subject belong to the field of chemical ecology. I would like to talk briefly about the semiochemical. Have you ever heard about the semiochemical? For example, in the early morning, if someone bring a coffee to you, you know, oh, coffee come. That means some information in the air about the coffee. You can recognize or you can receive it. And this called semiochemical. Semio means signal and chemical. That means the signal chemical. And here is a definition about this. Semiochemical are chemical compound, commonly organic compound, carrying signal that function in communication between living organisms. And depending on the scope of activity, semiochemical are divided into class. First is the pheromone. Pheromone is intra-specific activity. That means the action between the same individual in the same species. And the other group is allelochemical. This act is interspecific. That means from individual of a species to another individual of other species. And I give an example because about the interaction between plant, insect, pet, and animal enemy. So the two way of interaction, first attraction and the other repellent. For example, the tree may produce some volatile organic compound to attract natural enemy, and the insects also fight the tree by some chemical emitted from the tree, and for host fighting, and it's also the chemical semiochemical, and the other the tree also produce some chemical to repel the attack. And for the same species activity we call pheromone, and the different species activity we call allelochemical, and it is the interaction between drop, damaged insect, and animal enemy. And how the semiochemical affects on the insect. The semiochemical mainly affects on the insect behavior, such as host, mass, and oviposition, fighting, and also defense. Because the activity, for example, the pheromone activity at the same species, so it's very highly specific, and the action at the very low concentration. So according to this, if we apply the semiochemical in insect management, it's low non-residual, not effect in the environment. And according to a report of Vigo in 2010, every year, more than 10,000 hectares will apply semiochemical for management of pest, particularly the sex pheromone. And until now, up to date, more than 6,500 semiochemicals have been studied, many of which are utilized as tools for crop protection. And this information in the very good internet database the Fairway website. You can see here, and you can come here for searching any semiochemical compound and any insect that produce what semiochemical. And in this website, this is the address of the website, the Fairway. For the sex pheromone is a semiochemical that stimulates the mating behavior. That means an individual is secret pheromone to attract another for mating behavior. And pheromone commonly found in Lepidoptera, Coleoptera, and Diptera order. The first identification of the sex pheromone is the bombicon. And this is the structure of the bombicon by Buchanan and his colleagues in 1999. And for identify the chemical structure of this compound, Buchanan has used more than 500,000 of bombicons, and it took a time about 10 years. However, today, because the development of organic chemists and also the analysis technique, so the identification of the chemical structure of sex pheromone compound is not so complicated and more easy than in the past. Just in the Lepidoptera only, today more than 680 Lepidoptera species have been dealt with their sex pheromone. And according to the chemical structure, sex pheromone are divided into type 1. Type 1 includes straight chain 10 to 18 carbon compound with a terminal functional group, commonly alcohol, acetate, and aldehyde. And this group accounting for more than 75% of identified pheromone components. The type 2 is straight chain, diene, triene, 17 to 23 carbon chain compound, and they are monoepoxy derivative, and this group accounting for about 50% of the identified pheromone. The other is not belong to the type 1 and type 2, and this accounting for about 10% of pheromone component. And here is the method for sex pheromone research. In this, for the pheromone quantitative method, if we deal with the large size moths, for example, some Noctidae, Viridae, each female contain about 1 microgram to 10 nanogram per a female extract. For small size moths, the content of pheromone is still very low, just about 10 picogram to 1 nanogram per female. And for example, the Citrus tulip minor, when I deal with this experiment, and we even not observe the mass spectrum of this species. For minor component, it contains just about 1 to 10% as compared with the major component. That means for minor component, the concentration is more lower, and it's a really challenge for the sensitivity of the instrument. And for dealing with the pheromone research, we also need to synthesize chemical, because synthesis is very important for you a standard to affirm the interaction between the analysis from the extract. And another thing is synthesis is used for field examination, and also it's a way to affirm again for the interaction of the identification. And also synthesis also we do some screening test for the new attraction and for the new work of pheromone research. Is it okay? Here.
Je ne sais pas pourquoi ça fait ce bruit là, c'est pénible, tu peux pas savoir. Je vais l'enlever le son. Moi j'ai un très bon son, ne vous inquiétez pas. Voilà, là on va moins entendre C'est quoi ce truc?
Just enough or one more?
Bon, on continue comme ça.
Yes. Something more. Here is some about the research on the insect semiochemical in the Mekong Delta. You know, until now, the totally 56 species of insects in the Mekong Delta have been dealt with their semiochemical, and in which Lepidoptera is most the highest number with 30 species. For the semiochemical, the set attractant, it contributes to about 17 species. The second group is the set pheromone. And the purpose of insect semiochemical research in the Mekong Delta, you can see here, 76% of the number of species have dealt with the semiochemical agricultural pests. This indicates the purpose for semiochemical research in the Mekong Delta is pest management. The second is almost the set attractant yield for about 69% of species, and this intended attraction is screening test for recognizing the insect species composition. So for chemical structure identification in the Mekong Delta now, totally 7 set pheromone of 7 species have been identified, and among the
Excuse me, je pense que c'est lié à ça. C'est possible.
okay.
On va essayer ça.
Maybe here. So something I can stand. Yeah, okay.
Ouais, je pense que c'est ça. On va l'enlever pour voir. C'est possible. Ouais.
Okay.
On va fermer.
Not necessary.
Non, it's not, mais. Alors on reprend.
Oh, okay.
Allez. Quand vous voulez.
Interestingly, among this, the Camenta mimosa is a biological control agent, and this species were imported into Vietnam in 1997 for control of the mimosa weed. And now we identification of its sex pheromone. And the other species are almost insect pests in the Mekong Delta of Vietnam. Some of them are very dangerous pests. For example, the bright endocarpa is the citrus spot caterpillar, the citrus leaf miner, and the other, the 7, is the sweet potato vine borer. And you think all the deal with sex pheromone research belong to Lepidoptera species. So this indicates that the study in this subject in the Mekong Delta is still limited. For synthesis of the compound, in here, totally more than 10 compounds are synthesized, and almost belong to the straight chain compound with monoamine compound, diamine, and also triamine compound. And all the synthesis are the straight chain sex pheromone. So in the future, we need more research on another group, for example, like the branched compound, for another group of insects, sex pheromone. And for application of the semiochemical in the Mekong Delta, Vietnam, there are a little bit diversified of application. The first is screening of species composition, and it's deal with about 75% species of identified insects in the Mekong Delta. The second is monitoring the population dynamics. That means for forecasting and for predicting, and also for timing the red-horn action. The third is mass trapping, used for reduce the insect population and to protect the crop, and making disruption is also same. The other thing is we use semiochemical in food and bone system. And you know the food and bone system commonly use the plant for attract or for repellent the pet. But in this situation, we use semiochemical instead of plant for also attract and repel the insect outside our crop. And in this, we just only now we just deal with only one species, in the sweet potato. We will. The other application of semiochemical is entomopathogenic contamination. In this, we use entomopathogenic fungi combined with the seed pheromone for contamination the population of sweet potato. We will. And the last application of semiochemical is for recording species establishment. So it's enough. Continue.